Hi, welcome back to the webinar series Building AI Agent Products, a four-part series where we move beyond the foundational concepts of AI agents to learn how to implement them successfully in your products. This is a third part of the series, Managing AI Agent Development Projects. Let's get started. If you've been following along, you know how to identify opportunities and design human-agent collaborations. Today, we tackle reality where brilliant designs means the unpredictability of AI, where the traditional project management collides with non-deterministic systems, and where teams have to navigate entirely new types of complexity. Here's the problem. The transition from design to implementation is where most AI projects fail. Traditional software projects have clear requirements and linear progress. When you're building AI agents, they're probabilistic, non-deterministic. They evolve and costs can spiral unexpectedly. Today, we'll learn how to adapt methodologies and practical frameworks and battle-tested strategies for managing AI agent development from kickoff to integration. Before we get to that though, let me tell you a little bit about me. My name is Elio Damaggio, and I have been building products in cloud, IoT, data, and AI for the last 15 years, all of them in Microsoft and AWS, where I'm currently head of product in the agentic code transformation space. I have a strong tech background, holding a PhD in computer science and a past life as a software developer. I authored a few patents and an RFC sender for the web push protocol. So if you receive notifications in your browser, it's also a little bit my fault. You can reach me through my LinkedIn page that's here on this page. Also, this presentation only reports my opinion and is not related to my current or former employers. Okay, here's what we're going to cover in the next 20 minutes. 5 sections, each tackling a different challenge you'll face when building AI agents. The first one is the AI development paradox. Why traditional methods fail with non-deterministic systems, and how to adapt agile methodologies when you cannot predict what's possible. The second section is the core development reality. How do you actually get engineers, data scientists, and designers to work together? How do you measure quality when correct is not a binary, is not a yes or no answer? The third section is what I call the 4 horsemen of AI projects. Those are like 4 things that tend to derail projects: scope creep, build versus buy in something that really changes very frequently, the need for perpetual iteration, your agent is never done, and cost variability. We're going to then move on and do a couple of deep dives on edge deployments, QA, and how integration with legacy system. And finally, we're going to look how to plan and how to get started delivering your AI agents. Let's start from the development paradox. How are AI agents different from building traditional software? Traditional methodologies, waterfall, agile, doesn't really matter. They all assume certain things. Same input gives same output. Bugs can be fixed definitively. Test coverage ensures quality, and requirements can be specified and fully verified. AI agents break every one of these assumptions. This creates what I call the AI development paradox. The more powerful your agent, the harder it is to manage with traditional approaches. Let's look at a customer service agent. In traditional software, you write test cases with expected inputs and outputs. But with your agent, it might handle the same inquiry differently based on context, previous interactions, or model updates. A response that seems reasonable might violate business rules you never thought to specify. This is not a bug, this is emergent behavior. That's what makes the agents so powerful, but also that's what makes it really hard to develop them in a safe way. The solution is not abandoning the existing methodologies, it's adapting them for this new reality. Let's start with Agile. That's a great foundation, but you really need to adapt it for non-deterministic systems. How do you estimate achieving 90% accuracy in intent recognition when you don't know if that's even possible? How do you commit to sprint goals when a model update could change everything mid-sprint? Here's how I think about it. We have to shift from delivery sprint to experiment cycles. Instead of committing to features, commit to learning objectives and hypothesis validation. Your sprint goals become determine if the agent can handle multi-step issues with 85% success rate, not implement multi-step handling. And here's something teams always discover too late. One of the core capabilities isn't what the agent does, it's being able to answer the question about what the agent can do. That's the core of your cycle. Users need to know the boundaries, stakeholders need capability documentation, support needs to explain limitations. Make this an explicit experiment early. Can you accurately define and communicate what your agent can and cannot handle? And that does require development, evaluations, and testing strategies. Each cycle then includes experiments, success metrics, and decision points. Are you going to continue to the next feature? Are you going to pivot to a different technique? Or are you going to abandon that feature or changing it in other ways? User stories become hypothesis statements with clear testing criteria and fallback plans. Daily stand-ups are not about discussing blockers and share, but they are sharing. They're about sharing experimental results and adjusting hypotheses. This experimental mindset changes everything about how you plan and execute for this kind of projects. Let's shift to the core of our methodology: cross-discipline coordination and quality metrics. When you build AI agents, you require a lot of coordination between disciplines that traditionally used to work in parallel or in sequence. Engineers focus on reliability, data scientists obsess over accuracy, UX designers struggle with handling unpredictable interactions from the users, and product management have to balance the user needs with the technical constraints. Without careful coordination, you have a gridlock. Or worse, you build an agent that nobody can actually use. To be successful, you need a shared language and metrics that bridge the disciplines. Instead of data scientists optimizing accuracy while engineers optimize latency, align around a user-centric metric like time to successful task completion. You have to create cross-functional rituals beyond the standard meetings. You want pair programming between engineers and data scientists. You want design workshops where UX and data science explore the patterns together. Think about how important this is when the model can change the conversation, changing the user experience. And finally, do behavior review sessions where all the disciplines observe the agent interactions together. Very important, you have to establish clear ownership. Who decides when a behavior is good enough? Who owns the cost capability trade-off? These decisions cannot happen in silos. Let's move to the metrics that you need for this. If you use traditional metrics, code coverage, defect density, mean time to resolution, you don't get a lot of value for AI agents. This is because your agents respond differently to the same query. Correct is kind of subjective, and performance can degrade without code changes. You need new approaches. And the challenge is not just technical, it's really a matter of approach. What does quality mean for a system that is designed to be creative and to be adaptive? You really need multi-layered measurements. What we have here is a proposal that I'm starting to utilize. Behavioral level, task completion rates, user satisfaction, and escalation frequency. Remember, that is the escalation from the agent to the user. Then there are, of course, technical level, response latency, cost per interactions, resource utilization. But very important, you need to establish qualitative reviews. Team members and stakeholders regularly have to review the interactions to identify patterns that the metrics are missing, which they could be really, really dependent on the use case that you're creating. Implement confidence scoring where agents self-assess responses. Create kind of an LLM judge or an AI judge that can look at a conversation, look at an interaction with a user, and understand if there was a good one, a bad one, and what are the cases where that has to be changed. Create benchmark suites, testing not just the functionalities, but also the edge cases. Create adversarial inputs. Try to have other AI agents simulate the user to try to explore a lot more cases that you can do manually, and implement graceful failures in those cases. It's really important to understand that quality in AI agents is not something that is binary, that you can just achieve and be done with it. It is always a continuous improvement. These are cycles and experimental cycles, and quality is fundamentally what tells you if you really implemented a feature or not. Adapting your methodologies, cross discipline coordination, and metrics are all necessary, and many teams get that. However, there are multiple aspects that can be surprising during your development, and I call this the four horsemen of the AI projects. Let's look at them. The first one, and I think the most insidious one, is that always or often, stakeholders think that AI can magically solve everything. Can we just have it also handle invoice processing? Or why can't it predict customer churn while it's at it? These requests seem reasonable because technically you could do all of these things. An agent could potentially do all of these things. This is especially true where every new feature looks just a prompt away. But the theoretical capability and the practical implementations are vastly different. Every additional capability increases the complexity exponentially, not linearly. Think about all the evaluations and test combinations that you have to perform. Broader scope means more training data, more edge cases, more unexpected interactions, and higher costs. And less ability to constrain the agent on the things that are useful. An agent may be able to handle 5 tasks okay, providing little to no customer value, or handle one excellently for a killer product. How do you defend your product from scope creep? Well, you have to develop a capability roadmap showing how abilities expand over time. Tie each expansion to specific success metrics from the previous phases. Remember, it's the cycles, it's the metrics, it's the QA, and you will see that going from one capability to the other would require specific capabilities in your process as well. Use agent personas to maintain the focus. Your customer service agent has a specific role that gets diluted if you start adding other capabilities. Are they really required all at the same time? Most importantly, establish clear out-of-scope examples early. Reference them consistently when new requests arise. How do you navigate the rapidly evolving vendor landscape? This is the next horseman. The vendor ecosystem changes so fast that today's decision might seem outdated in 3 months. You have new models with better performance, you have new platforms with easier integration, you have new tools that claim to solve your exact problem. Meanwhile, you may not have the expertise to build an in-house system that can give you all the control. However, that would also give you a lot of maintenance burden that you actually don't really want. Build versus buy is not binary, it's actually a spectrum. That is true in many cases, but in this case is especially true. If you cannot find an end-to-end solution that fits perfectly, the sweet spot may be in the middle, using foundation models from established providers, build custom orchestrations and some business logic, and integrate specialized tools that you may build or buy as well. Remember, when you evaluate vendors, consider the current capabilities. Does it do what you need? Roadmap alignment, behavioral stability of what you're buying, and support for your specific development architecture. Is it going to be only cloud? Can you deploy it in your own data centers? Create an evaluation metrics with all these characteristics and go from there. The next horseman is the real understanding on the part of a team that your agent is kind of an always perpetual beta state. Traditional software has clear phases: development, testing, deployment, maintenance. With AI agents, as we've already seen, they're never really done. You're always trying to improve them. They always have metrics. They may be good enough for you, but you always have to track and make sure that they don't regress. Things may change. Your vendor might update the model, changing the behavior without any action from you. The user interactions may reveal failure modes that you did not think about it and never happened until then. Competitors may deploy agents or raise the expectations. Your agent exists in a state of perpetual evolution. Successful teams embrace this. You have to build continuous learning loops in your process. As we already introduced, beyond CI/CD, you need to implement continuous evaluations, data collections, and experimentation. You have to use shadow mode deployment so that the new versions run alongside the production one, comparing responses without affecting users. You have to capture complaints, not only the explicit ones, but also implicit signals of confusion and frustration. We talked about this in the metrics slide. Establish regular behavior review cycles analyzing the interactions for improvements. This is not only when you're developing, but also going forward. This is your maintenance phase. Most importantly, to enable all of this, you really need to architect your own product for rapid iteration. You have to have modular components that can be updated independently, feature flags for gradual rollouts, and also rollback in case of problematic changes. Finally, this is the fourth horseman. This is a challenge that is unique to AI agents. Costs can vary dramatically based on user interaction. Simple questions cost penny, complex multi-turn reasoning costs dollars, and a new untested use case for your agent may come up, and the cost spikes can spike orders of magnitude. Traditional capacity planning assumes predictable consumption. AI agents, that doesn't work anymore. You need both technical and product strategies. On the technical side, you can look at token caching, model routing to cheaper models when possible, circuit breakers preventing runaway costs. On the product side, you need to study and input in the product interaction patterns that guide efficient usage without constraining the legitimate use cases. And of course, escalation pathways as well. Consider usage tiers that align cost with value, progressive disclosures, unlocking expensive capabilities only when they're needed, and transparent cost indicators, helping users understand resource consumption. You have to build cost monitoring from day one. By the time you get to your monthly build, it's going to be too late. Let's look now at our technical deep dives. Here we're going to talk about edge deployments, Q&A, and integrations with legacy technologies. Let's talk about edge deployments. When you deploy AI agents locally, servers that are on-premise or regional data centers or local PCs, you inherit challenges that are not there when you're in the cloud. Cloud gives you centralized monitoring and automatic scaling, unified updates. When you're local, each instance is its own island that somehow needs to stay coordinated. The first challenge is latency and routing. Your agent must decide what gets processed locally and what has to go to the cloud. This routing logic has to be sophisticated enough to both maintain response times and also smart enough to know its own limits. Users don't care where processing happens, they care that it's fast. Local data integration is also a nightmare. Your agent must connect to on-premise database, legacy system, and local file stores. None were designed for AI. Unlike the cloud, where you control everything, local means working with whatever situation already exists. Monitoring is especially painful. You cannot just check a dashboard. You need distributed logging that aggregates data without killing bandwidth, detects struggling or offline agents, and provides debugging when you can't access production directly. It's really hard to debug an agent that's running on a customer server you'll never touch. And think how hard it is to gather the data and the feedback that you need to actually maintain your agent to be productive and to be of high quality. Other situations are updates. Think about model updates or your own agent updates. You need rollback capabilities for each location, test environments before broad deployments, and ways to handle version mismatches when location A updates but location B doesn't. One bad update can break hundreds of deployments simultaneously. When you deploy locally, it's not just cloud deployment copied in different servers. It's a completely different beast that requires different architecture, different monitoring, different everything. With all these challenges, how do you ensure quality? QA for AI agents requires a fundamental rethinking of the testing principles. You look at unit tests, but they usually verify specific function outputs, this is not particularly relevant when the behavior emerges from model interactions. When you look at integration tests that have to check the system boundaries, now they have to account for non-deterministic responses. What are the exact boundary? How is that defined? It's really hard to just say yes or no. When you're validating a workflow with end-to-end tests, now you have to handle workflow that change in order. Different steps are appear in different position and at different times, while maintaining the validity of the whole workflow. With traditional QA, you rely on deterministic behavior. Now, you cannot, it's really hard to reproduce the exact bug because the bug condition isn't frequently not fully specified. This is how we should think about addressing these challenges. We talked about continuous evaluations, but how do you create them? You need property-based testing that verifies behavioral characteristics, not specific outputs. For instance, the agent never recommended a policy violation, not agent responds exactly with something. Statistical testing that runs interactions hundreds of times, identifying response distributions and outliers. And finally, you have to look at adversarial testing that probes many failure modes. As I was saying before, think about of an agent that is simulating a user and starting to look at many different conversational paths or interaction paths that are really hard to test manually or even to write explicit tests on. In addition to all these automatic cases, establish human-in-the-loop QA, where testers interact naturally, identifying issues that automated testing misses. Remember, it's really important. QA for AI agents is risk management and not bug prevention. You're identifying and mitigating potential failures. It's really hard to just to be absolutely sure that certain things will not happen. For those, you will have to add deterministic ways to do it. But what is in this bucket and what is outside of that bucket is part of this risk management. Let's look at the last challenge. You have to move beyond testing in isolation. Assuming you did everything that we already talked about, you have an agent that works amazingly, that is tested, it's continually evaluated, and everything works. The thing is that agents always need to integrate also with existing systems to be effective. They have to access enterprise databases. They have to respect authentication frameworks, comply with audit requirements. This creates complex dependencies that can derail the whole project. In this case, this is not fundamentally different from other systems. But your agent might work perfectly well alone, but fail when the customer database is slow, when the CRM API changes, or when the security policies prevent storing conversation context. You have to manage the integration complexity by treating your agent as part of the ecosystem and not standalone. Map the dependencies early, identify the critical versus nice to haves, and create abstraction layers that isolate your agent from direct dependencies. You have to be allowed to block external systems during development. It's important to establish clear contract with platform teams about API stability, performance requirements, and change notifications. You have to design a graceful degradation. Maybe it cannot access the purchase history, but it can still answer product questions. Implement comprehensive monitoring, tracking, not just for agent performance, but for dependency health and integration latency. It's really critical to involve the platform teams early and not as a final step. We're nearing the end of our time. And how do we plan and deliver these agents? The last of the hardest parts of AI agent developments is setting the timelines. There are fundamental uncertainties in this project, and it's really hard to do that. With traditional projects, you were able to provide dates such as feature complete by February and deployment by March. With AI agents, how long does it take to achieve 95% accuracy? It's unclear. What if 95% accuracy is not even achievable with current technology? How do you estimate handling edge cases when you don't know all the edge cases? Traditional project management assumes that you can decompose work into estimable tasks. AI development involves unknown unknowns that emerge through experimentation. We talked about this already. We need a shift from deadline driven to milestone driven planning. Instead of delivery dates, establish learning milestones with go no go decisions. By month end, we'll know if the agent can handle basic inquiries with acceptable accuracy. If yes, we're going to proceed to the next feature, complex inquiries. If no, we will adjust the approach and reconsider scope. You have to communicate in confidence intervals, not just point estimate. You'll be 80% confident in basic functionality in 6 to 8 weeks and 50% confident in full functionality in 3 to 4 months. Create dashboards that shows progress and uncertainty so that you can help stakeholders understand why the timelines shift. It's really important to celebrate learning and pivots as progress, non-failures. If you discover that an approach doesn't work, that's valuable information that brings you closer to a solution that will solve your problem. What are the next steps? We now have a framework for managing the challenges that arise when implementing AI agents. Going from design to deployment doesn't have to be chaotic, even if you're dealing with non-deterministic systems and capabilities that evolve at all times. You can start by adapting the methodologies to embrace experimentation and uncertainty. Build cross-functional teams that share vocabulary, metrics, and decision-making. Establish quality framework measuring what matters for agents, not traditional software metrics. Importantly, AI agent development is as much about managing human factors as the technical challenges. Look at scope creep and unrealistic expectations and fear of uncertainties. They all can derail projects just like technical failures. It's really important to embrace the iterative nature. The first deployment is just the beginning of the continuous improvement of your agent. Always measure, always evaluate. With this, we reach the end of the session. Thank you for listening for the whole one. If you have found this interesting, you may want to listen to the next webinar, where we'll explore launch and scale, monetization strategies, accounting for variable costs and user adoptions, building trust with the user, scaling from pilot to production. We'll take everything that we looked at from opportunity identification, design, and implementation, and really try to see how we can build a sustainable business around an AI agent. I really thank you for your time, and I look forward to continue this journey with you in our next session. Feel free to reach out to me through LinkedIn. Thank you.